Hello students, welcome back to Future Foundation. Students, in today's class of vectors, we will learn the concept of vector triple product, scalar product of four vectors, and we'll do some questions based on them. Then we will also introduce the concept of reciprocal system of vectors. So let's get started. So students, write down the first heading, vector triple product. So in this, we will write point wise. Point number 1, it is represented by A cross B cross C or B cross C cross A or C cross A cross B, assuming A, B and C vectors are given vectors, right? Now, so there are three vectors, then their vector triple product may be defined like this, okay? So this is a vector product because V cross C is a vector and A vector is another vector, and between them there is a cross, so product becomes vector product. And triple, in the sense, why it is called triple product, because we are using three vectors. Okay, now point number 2, how we can expand this product, let us understand. So here three vectors are there, say this is 1, this is 2 and this is 3. So we will expand in this manner. A dot C times B minus A dot B times C. Okay, so first I will write 1, 3, 2 and then I will write 1, 2, 3. Okay, now understand geometrically. A cross B cross C is what? Suppose here this is B vector, this is C vector, and B cross C is the vector perpendicular to the plane of B vector and C vector, right? So this is B cross C. And see, if this is A vector, A cross B cross C will be, this is A cross B cross C, which is perpendicular to B cross C and also perpendicular to E vector, right? But if this is B cross C, this is A cross B cross C, which is perpendicular to B cross C, right? And also B cross C is also perpendicular to B and C, so it implies that A cross B cross C is a vector lying in the plane of B vector and C vector. So we can say A cross B cross C is a vector perpendicular to A vector and B cross C vector, right? But B cross C vector is perpendicular to B vector and C vector. It implies that A cross B cross C will lie in the plane of B vector and C vector. Okay, so make a point, B cross C is a vector perpendicular to a vector and lies in the plane of vector and C vector, right? So this is a vector. So A cross B cross C is a vector perpendicular to A vector and lie in the plane of B vector and C vector. Okay. So let us take a question based on this concept. Find a vector coplanar with I cap plus j cap plus 2k cap, comma I cap plus 2j cap plus k cap and perpendicular to I cap plus j cap plus k cap. Now suppose if this is p vector and this is c vector and say this is a vector. So question is demanding for A cross B cross C. Means we have to find a vector which is perpendicular to this vector and lies in the plane of this and this. Okay. So simply it means we have to find A cross B cross C. Okay. So A cross B cross C by definition is A dot C times B minus A dot B times C. Okay. So see carefully. A dot C is a scalar quantity. So this is lambda times. This is lambda type. Okay. So lambda times B vector. Not between A dot C and B there is no dot because A dot C is lambda type, right? So we are writing like lambda B times. Okay. Similarly, we are writing A dot B as mu. So this is whole as mu C type. Okay. Okay. Don't get confused. Now A is 111 dot C is 121 times B, that is 112 minus is 111 dot B is 112 times C, that is 121. Okay, so this will come out 1 plus 2 plus 1 times 112 minus 1 plus 1 plus 2 times 1 2 1. Okay, so this will be 4 I cap plus 4 j cap plus 8 k cap minus 4 I cap minus 8 j cap minus 4 k cap. So this will be minus 4 j cap plus 4 k cap. Right, this is the required answer. And this question was asked in JEE. Okay, JEE 2011. Okay, now next question is, if A cross B cross C is equal to A cross B cross C, then A vector, angle between A vector and C vector is equal to question mark. Again, if I am expanding this, I will write A dot C times B minus A dot B times C is equal to A dot C times B minus A dot B times C. So A dot C times B and A dot C times B cancel out. So this will be A dot B times C is equal to A dot, sorry, this is B dot C, B dot C times A. This will be B dot C times A is equal to A dot B times C. Okay, this is lambda A vector is equal to mu C vector, or you can write A is equal to mu by lambda C vector, or this is like A vector is equal to KC vector. So from here we can say A vector is parallel to C vector, right? So angle between A vector and C vector is either 0 degree or 180 degree. Okay, let's take another question. Question is A cross B cross C plus B cross C cross A plus C cross A cross B is equal to question mark. Again, if we expand, so this will be A dot C times B minus A dot B times C plus B dot A times C minus B dot C times A plus C dot B times A minus C dot A times B. So A dot C times B and A dot C times B. इसी तरीके से A dot B times C, A dot B times C, B dot C times A, B dot C times A. This will be 0. So answer is 0. Okay. Next question. Question is if mod of A vector is equal to 2, mod of B vector is equal to 3, and A vector dot B vector is equal to null vector or 0, find mod of A cross A cross A cross B. Please see carefully. In this, what I'm going to find here. I'm going to find vector product of 4 vectors, right? So we will see how we can find vector product of 4 vectors as well. So take A vector as it is, and in this we can use the concept of vector triple product. A dot B times A minus A dot A times B. So from this we can have A dot B. A dot B is 0, so this will be 0. So A cross minus of A dot A, which is mod of A square, which is 4 times B, which will be mod of minus 4 is 4, so 4 times A cross B, and A cross B, mod of A cross B is mod A mod B sine theta, and theta is the angle between A vector and B vector. Here A angle between A vector and B vector is 90 degree, this is sine 90, which is 1, and a mod a is 2, mod b is 3, so this is 24. 24 is the correct answer. Okay, now again one question is again based on factor product of 4 vectors, that is a cross b cross a cross c dot d is equal to question mark. So how we can evaluate this? So for the time being, let us take a cross b as u vector. So u cross a cross c. Okay, dot d. So now in this we can use vector triple product concept. So u dot c times a minus u dot a times c dot d. So u is again a cross b. So a cross b dot c times a minus a cross b dot a times c dot d. So this is 0 as a vector cross b vector is perpendicular to a vector, so dot product will be 0. So now this becomes a cross b dot c is box of a b c times a dot d. This is the answer. Okay, now write some remark. Remark 1 is a cross b cross r cross c. So if I write, if I see last question, then what I am doing, I am writing r vector in place of e vector in second bracket. So it will become what? It will become box of a b c times r vector minus a b r times c vector. Okay, as simple as that. Second one is box of a cross b cross b cross c, b cross c cross c cross a, c cross a cross a cross b. So this can be written as box of a cross b, b cross c, c cross a whole square, and again box of a b c square whole square. So box of a b c whole to the power 4. Right, now let us come to next topic, which is scalar product of 4 vectors. So let us take 4 vectors a b c d for a vector, b vector, c vector and d vector. A cross b dot c cross d is called a scalar product of 4 vectors. Right, point number 2, a cross b dot c cross d can be written as a dot b cross c cross d, because dot and cross can be interchanged. So this cross is here and this dot is here. So why I am doing this? Because I know how we can find a vector triple product, right? So in this E dot P dot T times C minus P dot C times T. So after multiplying a vector inside, so this will become E dot P dot T, A dot C times B dot T, E dot C times B dot T minus E dot T times B dot C. Okay, and also we can write this as determinant E dot C, B dot C, B dot T, E dot T, and B dot T. Okay, let us write a question based on scalar product of four vectors. If E vector, B vector, C vector and D vector are unit vectors and E cross B dot C cross D is equal to 1 and E dot C is equal to half, find condition for A vector, B vector, C vector and D vector. So we have to find the condition for these four vectors. Now E cross B dot C cross D is 1. So I'm writing as A, B, C, D are unit vectors. So I'm using modulus of A, modulus of B, modulus C or modulus D. So for using this, I'm writing across B as A mod B sine theta 1 and 1 cap dot mod C mod D sine theta 2 and 2 cap is equal to 1. Okay, so mod A mod B mod C mod D 1. So this will be sine theta 1 sine theta 2 and 1 cap dot and 2 cap is 1. Again expanding and 1 dot and 2. So this will be mod n1 mod n2 cos theta 3, which is 1. So right hand side is 1. So theta 1 can be 90 degree, theta 2 can be 90 degree and theta 3 is 0 degree, right? So means A vector B vector are mutually perpendicular vectors. A vector B vector, A vector B vector. Similarly C vector and D vector and A vector B vector perpendicular vectors, so this will be A cross B. This is A cross B, which is also perpendicular to A vector and B vector. Similarly C vector and D vector are, this is C vector, this is D vector. So these two vectors are perpendicular vectors and also C cross D is perpendicular to D vector and C vector as well. Okay, and theta 3 is 0 degree. It implies what? It implies that C cross D and A cross B are parallel vectors. C cross D and A cross B are parallel vectors. Okay, it implies that A B C D, it implies that A vector, B vector, C vector and D vector all lie in the same plane. Okay, revise twice. Come to next heading, which is reciprocal system of vectors. First one is, if two systems of vectors are such that their dot product is equal to 1, then they are in reciprocal system of vectors. Okay, for example, for A vector, B vector and C vector, A vector dash, B vector dash, C vector dash are reciprocal system vectors if A vector dot A vector dash is equal to 1. Similarly, B vector dot B vector dash is equal to 1 and C vector dot C vector dash is equal to 1. Okay, means dot two vectors are reciprocal for each other if their dot product is 1. As simple as that. Okay, now how we can find the A vector dash, right? So for E vector dash can be P cross C upon box of ABC. I am explaining how A vector dash is P cross A upon box of ABC, because we need dot product 1 na? So now if we take dot product of these two, then it will be A vector dot P cross C upon box ABC. Now numerator becomes box ABC and denominator is already box ABC, so it will be 1. So similarly for P vector dash is nothing but C cross A upon box of ABC, right? And for C vector dash is A cross B upon box of ABC, because we need dot product 1. Okay, that's why I am putting A vector B vector A vector dash B vector dash C vector dash like this. Okay, now let us take a question. Question is, find reciprocal system of vectors for I minus j plus k, comma minus I plus j plus k, comma I plus j plus k. Okay, now these three vectors are A vector, B vector and C vector, and we need to find their reciprocal systems. So let's say this is A vector, this is B vector and this is C vector, right? So for A vector dash is B vector cross C vector upon box of ABC, right? So B cross C is nothing but determinant of I j k minus 1 1 1 fun on determinant of fun minus fun minus fun and fun. Okay, so this is I times fun minus j times minus 1 plus k times minus 1 upon 1 times 1 minus 1 plus 1 times minus 1 plus 1 times minus 1 minus. Okay, so 2j cap minus 2k cap on what? Minus 2 minus 2 minus 4. Okay, or you can say k minus j plus k on 2. This is what? This is a vector dash. Similarly we can have b vector dash and c vector dash. So students, for today's class we are done. Let's meet in next class. Till then, bye bye, take care.